We had no sound. Yeah, we had no sound. We do have sound now, so
Okay, can everybody hear
they
now?
they will be able to hear now.
All right, so let me restart over then. Well, I didn't say a lot of things. I said, hello, everyone. My name is Levent Gürdemir. I'm with UTA Planetarium Director, and here in the studio is Jim Bader with us. Jim Bader is the Program Coordinator of the Planetarium, and this is UTA Planetarium's live star stream. Well, that's great. I think that the benefit of having the audience over here, right? Otherwise, we wouldn't notice that our audio is not making outside. So
thank you guys for
Jim
your support.
is running an extremely complex machine. So there is a lot of things that he needs to take care of, and I think audio was
also, I want to use the excuse that we once again we don't have Jennifer with us today. So I'm doing an extra couple jobs that I'm not used to doing at the same time.
So are we short-staffed today?
We're a little short-staffed. Yeah, Jennifer is doing like stuff that's worthless. You know, like working on rockets in Houston. So she told me yesterday she got to go into a clean room. And do some work on a satellite or something. I don't. Is that maybe I wasn't supposed to say that publicly, but it's too late now.
Yes, keep the secrets, please, out of here. So, hello, Braxton. Hello, Janet and Kurt. So you are regulars. That's great. So if you have questions or anything to share with the entire world, please let us know through the chat. And here there is a lot to talk about, right? I think we need to start because you have an extensive list, Jim.
Yeah, I don't know if we're going to get through the whole list.
Yeah, most important thing of this morning's was, I think, the lunar eclipse, right?
Yep, definitely.
The headlines talked about super blood flower moon.
I love that the news organizations and so on and so forth put that in there. You see the blood flower moon. I feel like those two words are contradictive. Maybe I'm wrong, but you know, blood is a violent word to me, and then flower is the opposite. So, do you want to explain how ridiculous the whole name is anyway?
It is.
Yeah.
So a lot of people ask me, like, what is blood moon or bloody moon? What is super moon anyway? So I mean, these are just the words that it's funny. I don't know. I mean, the super moon is invented by media. I always say that there is no super moon concept in the astronomy books.
We can show it later. We can show them the sheer difference in size a little bit later on.
Another thing that catches my attention is all the headlines have also sub-headline says it's a very rare event, and they are talking about how rare it is. Like, oh, the next one is going to happen in 1600 years or a couple thousand years. But if you look at that, the lunar eclipses happen quite often, and in each occurrence, and supermoons as well, but in each occurrence the headline says it's a rare event. Well, they say it's a rare because every supermoon or every lunar eclipse has its own characteristics. And if you would like to repeat the exact same thing, yeah, you find yourself in the magnitude of thousands of years wait time for them. But the problem is it's not very significant event, and like, for example, the super bloody flower, and let's decode what it means anyway. So super
I just wish that it was also a blood or a blue moon too, just to add one more adjective to the list. Super blue blood flower moon.
Like it is getting to the point, like, you know, the complex coffee orders, and sometimes there are, like, 30 words that needs to come together to explain a specific type of coffee. So it is similar to that. So anyway, let's decode this thing. What does it mean?
I just need to cut in, Levent. Kurt's comment is just yeah, some kind of carnivorous plant, a blood flower. Yeah, that's what it sounds like. I think to me. I agree with you, Kurt.
Well, the lunar eclipses are sometimes interesting events because the problem here is the lunar eclipses happen quite often. It happens during a full moon. Why? Because if the lunar eclipses happen because Earth blocks the sunlight that goes to the moon. So when the sunlight, to block the sunlight, Earth has to situate itself between moon and sun, otherwise cannot block the light. And in this configuration, moon is always full moon to the observer who is located on the surface of Earth. So in this case, the lunar eclipse happen. When the lunar eclipse happen, the sunlight is blocked. Well, in theory, the moon has to be dark. Like through the surface, it has to be dark, but it doesn't happen during the full moon. Why?
What? I don't know.
Why the moon is not completely dark during a full moon? Well, there is one thing important, and it is the air around Earth. The air refracts the light, just like prism refracts the light, and what you see is a rainbow at the other end of the prism. The Earth's air do the same thing. So in theory, the moon, the sunlight is completely blocked and it doesn't go to the surface of the moon. Actually, Earth's refract the light, and some of those refracted light falls on the moon's surface. So moon is not completely dark. But here's a problem. Refracted light is spread into colors. So when the light spread it into colors, then remember the light, there's a rainbow, the spectrum of light at the other end, and that rainbow, only the part of the rainbow goes onto the surface of the moon, and that is the longest, the shortest frequency, the longest wavelength, which is the red color. The red color that falls onto the moon's surface. Brexton says, because the Earth reflects light to the moon, well, it doesn't reflect in this case because the light is coming from the opposite direction. I would call the Earth's air refracts the light, and that make it fall to the moon. Yeah. Otherwise, it would just avoid. So
that confusion with refraction and reflection is common. I think that Levin can also attest that even in the astronomy classes, refract and reflect are...
So moon reflects the light. It bounces back from the surface of the moon. The Earth's air refracts the light, which changes the path, just making it maneuver a little bit. And for this case, only the red color falls on the moon's surface because the higher frequencies like the yellow color, green color, blue color are refracted less and doesn't make enough bending to fall onto the moon's surface. But red light is affected most. It refracts and falls on the moon, and that gives the red tint on the moon's surface. So the red color actually comes from the Earth's air refraction of the sunlight. So that's why we see somewhat red color, red tint on the moon's surface, and somebody calls it bloody moon, which is a name I don't like, but that's why it is red. Here is the problem. The intensity of red tint is not always can be estimated and calculated precisely. Well, there's a lot of factors going into that, and the intensity and magnitude of the lunar eclipses is very much unknown until the last hours or last minutes. So we cannot predict how intense it's going to be. And there are some lunar eclipses that you don't notice anything. The moon just gets slightly dimmer, but the moon gets dimmer from for any reasons, like the sky may be a little cloudy, and those clouds may also dim the light. Those clouds may be invisible, but even the humidity in the air may dim the light. So we don't notice, and some lunar eclipses are not really noticeable, but some do. Like this morning's one was an intense one.
Yeah, this is way more intense than I thought. For some reason, I thought that this was going to be a light one. We're on the edge of the visibility of it, but it was cloudy where I lived. I don't know about you, Levent, but I couldn't see it. So at 6 this morning, it was way too cloudy for me to see much. But I got to work and I ran the simulation, and we're going to do that for the audience in just a moment. But super red. Super red. So, Kurt had some comments here. I read that a 1-inch wide laser pointed at the moon would be 6 inches wide by the time I think bigger than that. I think a lot bigger. I'm like maybe 6 miles. I don't know. But
well, the laser pointers they are not powerful enough to actually send the light all the way to the moon. So
definitely not one that we can hold in our hand.
They go up in the air at some certain distance, but there is like the famous experiment done by McDonald Observatory. They actually shot a laser to the moon, and they sent the laser beam to the moon, and that laser reflected from the moon's surface and came back, and they measured the time delay between the time they sent the laser beam and they received the laser beam. And we know the speed of light. From that, they calculated the distance of the moon by using a laser beam. So the moon's distance can be precisely measured by using lasers. But they just not use the laser pointer like the pencil ones. They used a highly powerful
big
laser source.
It has its own closet. So we had some comments. Brexton says, I wish we could film these items and show them. We're going to show you guys images from all over the world, or a few places around the world, of the eclipse. And we're also going to show you right now, if that's okay with you, Levent. Let's go through the simulation of what it would look like.
Okay.
A little bit faster. So I'm going to, actually I don't have to move out of the way, but I'm going to for the sake of it. This is going to be 5 times faster than it would have normally happened. And in the eclipse right now, right beneath me, you guys can see it's already started. So this has got into the penumbra, I don't know if I said that right, where you can see a light orange color hit the moon, and then
this is Scorpius constellation, right?
Yes, definitely. My favorite star right next to it. And then I also want to point out that the moon is quite a bit bigger than it should be. I'll give you guys the details on how much bigger, just for the sake of being able to see it easy in the screen. So let me pop off here and then start the simulation. Anyway, let's go ahead. This is 5 times faster than it will occur. And let me know, Levent, if you want to stop it. You can see the actual umbra coming on now, the dark red. And I'll stop it right at the darkest. This would be the full blood moon, which is just crazy.
Okay, in this case, the moon is completely in the shadow. Again, in theory, it needs to be completely dark, like a black hole. We cannot see it. But the Earth's refraction makes it still illuminated, but only red color falls onto it, so it glows in red color. So it's a dim,
looks awesome,
red moon during the lunar eclipse.
Super cool looking. All right, and we'll go ahead and let it finish, and you guys can see that here in North Texas, it's going to dip below the horizon, and we don't get to see it undo itself, and you guys can see the atmosphere is returned. Since it's gone at this point, I want to go ahead and just back up quite a bit so that we can show the supermoon differences. Right now, for this experiment, the moon was 9 times larger than it typically would be in our sky. But for the sake of it, let's reset the moon. This is how it would have actually looked in the sky. And then, Levent, are you ready to show them the difference between a regular moon and a supermoon?
Yes,
Here we go.
I'm super excited.
Did you see it? Did you see it?
Yeah, that's very accurate. So, yeah, the moon has elliptical orbit. It is not perfectly a round orbit. So, like every elliptical orbit, it gets slightly further and slightly closer when orbiting. And of course, when it gets closer, the moon appears little bigger because it's closer. But the difference is that much.
I'll do it again. This is regular moon for everybody who's watching, and then if you're paying attention, on 3, 2, 1. I mean,
Super moon.
yeah, and I also have to say, Levent, this wasn't 7%, which is what you would expect. I actually had to increase its size by 14% because you literally couldn't see it. There's not enough pixels to portray it. So I don't know. Whatever.
Well, take a look at Kurt's question.
right.
If we were standing on the moon, what we would see?
I guess we could just go there. I think it's possible,
Mhm.
right?
Yes.
Let's see what happens. We're just gonna do that, you guys. Please bear with us while we go to the moon. I'm really curious as to what's gonna happen. We're
Well, in this case, because the moon is in the full moon phase, if you are standing on moon, it will be the opposite phase for Earth, so the moon will be in the new phase. So in the new phase, we would just look at completely dark Earth, but because of light pollution, we may still see like some city lights in the continents, but we should see some like a red ring around the Earth, and it is coming from the Earth's air. So
this is up close.
yeah. So right now we are looking at the moon. If we can turn the camera the other way.
Let me try to do that.
And
Give me just about.
sure.
I need you to stall event for 20 seconds.
Sure. Would you like me to get the Xbox controls?
Not yet.
Okay. We also have a super control device to drive our planetarium, which is an Xbox controller. But yeah, that's a good question because that's always wondered. We are seeing faces on the moon, but if there is an observer and somebody on the moon's surface, so how would Earth look like? And yes, Earth is also changing faces. Well, but not much, not like the moon, but it is also going through the phases and phases through phases for somebody on the moon. And the lunar eclipse is a perfect example because the moon, the Earth will be in the new phase, which is going to be just dark round in the sky. So here we are changing the camera direction. Is Earth in the view? So because it's in the new phase, we may not be able to see Earth.
We're looking at Earth. Well, we're looking up from the surface of the moon, and I don't really see Earth. So whatever that's worth.
Mm-hmm.
Wild. I expected to see a little bit more red. You can kind of see. Maybe I don't know if the Xbox controller would work, but you might be able to turn downward to see the dirt. You can see it off to the edges. Down here, just off to Levent's left. Interesting, though. Either way.
All right. There is another question. When the next lunar eclipse? So there is a lunar eclipse calendar posted on the web. You can find in many sources, but there is also, I think, the NASA and some of the government sources that lists lunar eclipses. Because lunar eclipses are not best view from the entire world, so depending on your location, they will list all the possible lunar eclipses. I don't know when is the next one, but again, it happens quite often throughout a year.
I can try to look that up just a little bit.
Okay, are we looking at the Earth right now?
We're on the surface of the moon, and we're looking at the Earth, and as you can see, the sun is directly behind it.
Okay, yeah. The sun is not entirely, the Earth is not entirely covering the sun then, right?
Yeah.
So the sun is forming a ring, but this ring of light passes through the Earth's atmosphere, being reflected, and the red color is intensely fall on the surface of the moon, turning the moon into whatever they call bloody. Great.
All right. Kurt says, thoughts and comments on the Chinese Mars. We're going to get there, Kurt, I promise.
Kurt is ahead of you, Jim.
It's on the list. We're getting there. We took a lot longer with this than I think we expected, but at the very least, I'll make point to get to that, Kurt, because it's super cool. Anyway, let's go ahead and let's see some of the pictures. We had some really cool pictures with everything, so let's just hop over.
Just before I move on, just the information that I found, there is going to be 4 total lunar eclipses in 2021 this year.
Ooh.
So we just seen the first one.
Nice,
So
fantastic.
I can assign the homework to you. Just find out the other 3, the times, and post it on our social media.
Can we see it, though? Oh, yeah, don't worry. We definitely will. Speaking of social media, I think this means I need to pop on. I may have had a small miscommunication and wrote something down wrong. If you saw the social media, the eclipse happened this morning, by the way. Still kind of a supermoon, but we mixed a date up, so just ignore that. Anyway, this is the way the moon looked from Taiwan this morning. I thought that was pretty cool. This is you can see it getting extremely red there. And then we could also move over and show the way it looked, not from Taiwan, but from New Zealand. So this is how they saw it in New Zealand. Pretty neat. And then last one, this was special for Levent. I set this up.
Surprise for me?
Yeah, surprise for you. Not everybody got to see a beautiful...
that's the picture of Anıtkabir in Ankara.
Yeah. And we have the image credits here for all of these. We definitely didn't take them, and I picked them up from CBS viewing the moon from around the world with the eclipse and the supermoon. I just thought they were kind of neat. These photos of the moon where it looks enormous are so cool looking. They look fake, and I just realized how perfectly my head is in the moon. Just nailed it.
Wow. I love that picture. That's great.
Yeah, super cool. All right. Should we just skip through everything, Levin, and just try to go straight for the Chinese
yes
rover lander?
Yes. Let's talk about.
Okay, we're running out of time, so we got to get to this. Let me get that set up. Okay, we're ready to jump into that. Ta-da! News alert. It is confirmed, at least as far as most people can tell, that China has successfully landed on the moon, and they did on Mars. Sorry, and they did something first. This is the first time that any country, whether it be Russia or the United States, has done 3 things at once. They successfully landed a lander after deploying a satellite around Mars, and the lander carried with it a rover. So this is like a 3-in-1 mission. They had to catch up to the United States, and they had to do it in a single mission. And it's pretty fantastic that this happened. We got some really cool images from it, but also this means we're going to get more science from it, which I think is a good thing, as far as I'm concerned. Let's go ahead and show the first images. So on the left, we have the first image that came out. It's in black and white. This is the rover taking a photo from its lander. You guys can see the tracks it's going to use to slide down onto the surface. And then on the right, we have a color image taken from the rover. I think this is of everything. I have to be honest, I couldn't find a lot of good sources on this. I don't know if you understand any of that, Levent, but I just couldn't find anything that I was like, this is concrete, definitely from the Chinese Space Department or Space Association. So a little bit rough. But either way, this is fantastic news, I think. At least as far as I'm concerned. We have one more image I want to show of it real quick, just so people can see it. And this is just a little bit about the rover. It does have a ton of cameras and other things that we would see on rovers we would send. So, for instance, I'm not sure exactly what this is, but it says, I don't know if you want to point to it, Levent, Wind Field and Sound Probe. Is that a microphone? Does that mean a microphone?
Yeah, it sounds like.
Sounds like it. other stuff, cameras and things you might expect to see with any other rover.
Well, that's great. There's this great competition in space.
Yeah, yeah. I'd say so. Pretty neat, though. I think that we now have three working rovers on the moon. Curiosity, Perseverance, and then Tianwen-1 rover, which may have a name. I couldn't find a lot of evidence about it. But I did want to point out one thing. Since Kurt, seems like you were ahead of the game here. You were looking at this. If you Googled this at all, Kurt, and you found some stuff that seems a little confusing, I want to talk about it because I just think it's really funny and unfortunate. Not in I'm laughing at, but I'm just laughing about the whole situation. So let me jump into this, Levent. I don't know if you've seen this, but let's go through this. So this is Chinese Space Agency's Twitter, as far as I could tell. Doesn't have a lot of followers, but I want to point out one tweet from get right beneath me from April 24th. The tweet is, "With great ceremony, we announce the confirmation of intelligent life." What do you take from that, Len?
Well, I think it's Google Translate.
Yeah, it has to be translation. I looked further into it. Apparently, that's just what it is. It's just like a weird translation. They're not. The Chinese Space Agency is not delusional. I mean, they successfully landed a rover on the surface of Mars.
Because I also speak multi-languages, I've seen a lot of significant translation errors. The Google Translate is a great thing. If you have no idea in the text, at least it gives you idea what is the text about. But it is not so accurate that sometimes it makes mistakes like these. And maybe this word confirmed meant to be a different thing in the Chinese language, and it was maybe like the investigation word is confused with the confirmed word by Google Translate or something else, and the word came out as it is confirmed the existence of intelligent life.
Yeah,
we know it's not confirmed.
There are some other.
Not the intelligent life. Life is not confirmed. Beyond let alone the intelligent life.
Yeah.
The intelligent life is just, it has to be, I'm not sure if we are intelligent. I have thoughts on that, but we are thinking like, the intelligent life can just, think, build, and calculate, communicate. So it has to have those type of the specialties, features, characteristics. But again, I'm not sure about us being
certainly there are times when I feel like it's debatable. The last tweet, and really the one that just kind of solves the problem of the translation, is there is certainly life on Mars. We're the life of the party. And they're clearly talking about, hey, the robot life is there. But it's pretty cool, though. I think it's neat. This is just more science, right? As a scientist, you're not probably concerned like, oh, China got there, we have to get ahead of them, space race again. But this means we're going to have more science coming. We're going to learn more, and that's awesome. Yeah, pretty sure it's a zing about the U.S. not being intelligent. Well, when I did a little bit of research on this, I discovered that Russia has not had a truly successful landing on the surface of Mars. That feels bad.
I was thinking about the all of us, like humans on the entire planet, not pointing particular region.
Okay. Well, we ran out of time, which means I have plenty of stuff for next week. We have stuff on the back burner that I really wanted to get to. Stuff about Mars, some crazy hopes for the future of U.S. spaceflight, and warp drives. But we'll have to get to that next week.
All right, sounds good. Warp drives.
Yeah.
Okay.
You'd never guess. I'm
All
just
right.
kidding. You could, but anyway.
Well, if that's true, we can just achieve the speed of light and just be at some other place in the universe in pretty much no time or short amount of time, right?
Warp drive's faster than the speed of light, Levent. We don't need to care about the speed of light, which has, I mean, you just imagine the problems with that.
I do have a problem because universe has a limitation with the speed of light, because if anything exceeds the speed of light, the physics breaks.
Yeah, it doesn't make sense.
So, and when the physics breaks, I'm not happy because why? Why wouldn't you? Why wouldn't I be happy? Okay, you need to start doing a 1 hour show. Kurt says, well, it's almost 1 hour anyway.
We pushed it a few times.
We always plan for, like, you know, we say 25 minutes and 30 max, but we always exceed anyway. But
Yeah.
all right, we'll try. We'll try to maybe, rather than the extending show to 1 hour, I will just maybe make a better point and compact the show into 30 minutes.
Yeah,
But still deliver a lot more.
I do have to say, Kurt, I appreciate it. It's that to me is a fantastic compliment. But 1 hour means I have twice as much work to do for every one of those shows.
Well, see you next week.
Yeah.
We'll be here, Jim will be here, and I will be here, and we'll see you next week with more topics.
All right, see ya.